Epicon tutorial.
Everyone, we are solving the second order nonlinear differential equation by Adm decomposition method today. So our equation is d square y dx squared plus 3dy dx plus y squared equal to 2. And with the initial conditions, y of 0 equal to 0 and y prime of 0 equal to 1. So as usual, in our previous videos, we've explained the procedure involved in the application of Adm decomposition method. So today, let's quickly apply it. So in an operator form, we can write our differential equation as Ly equal to 2 minus y squared minus 3 y prime of Ly is equal to 2 minus 3y prime minus y squared. So our integral operator is a twofold and it is assumed to exist. That is, our integral operator is 0 to x, 0 to x dx. So applying the integral operator, so we'll have L minus L inverse of 2 minus L inverse of y prime minus L inverse of y squared. So, and this will yield y of x equal to L inverse of 2 minus L inverse of y prime minus L inverse of y squared. Applying the initial conditions, we will obtain y of x equal to y of 0 plus x over 1 factorial y prime of 0. This can equally be written as x raised to power 0 of 0 factorial. And if it's a third order, we can write it as x over 2 factorial y prime prime. So, but this is a second order differential equation. So plus L inverse of 2 minus 3 L inverse of y prime minus L inverse of y squared. So we have our y of x to be y of 0 plus x y prime of 0 plus L inverse of 2 minus L inverse of y prime minus L inverse of y squared. According to Adm decomposition method, the following terms can be merged together to be our zeroth term. So that is, our zeroth term, y naught, is equal to y of 0 plus x y prime of 0 plus L inverse of 2. Then the remaining terms can be written as the recursive formula as negative 3 L inverse of y prime negative L inverse of y squared. So let us obtain our y naught. Our y naught is equal to, from the initial condition, y of 0 is 0, y prime of 0 is 1. So that gives us y of 0, this is 0, plus x plus double integral of 2 dx dx. We'll have x plus x squared. So this will be our zeroth term. So then the recursive formula yn plus 1 equal to negative 3L inverse of y prime minus L inverse of y squared can be written by Adm series as yn plus 1 equal to negative 3 L inverse of n equal to 0 to infinity y prime of n minus L inverse. For our nonlinear term, we have discussed that in one of our videos, how to obtain the Adamian polynomial. So this will be decomposed by the Adamian polynomial series n from 0 to infinity of a n. So when n is 1, but before then, our n we said is y squared. We should not forget that we have obtained the Adamian polynomial for this one when we considered the calculation of Adamian polynomial for some examples like this y squared. So then we obtained a naught to be y naught squared. We said when your n is 1, the Adamian polynomial for this is going to be 2 y naught y1, and then for n equal to 2, the Adamian polynomial is going to be y1 squared plus 2 y naught y2. So implementing this at n equal to 1 for our recursive n equal to 0. So we're going to have y1, that is this our recursive relation now. This we're going to have y1 equal to negative 3 L inverse y naught prime minus L1 a naught. And here our a naught is y naught squared. So this can be written as negative 3 L inverse of g dx of our y naught minus L inverse of y naught squared, because that's how to obtain the Adamian polynomial for a naught when we have y squared. Then we can say this is L inverse into g dx of y naught. G dx, our y naught is x plus x squared minus L inverse of our y naught solving this further, 3 L inverse of 1 plus 2x negative L inverse of x squared plus 2 x raised to the power 3 plus x raised to the power 4. And then finally we say 3 0 to x 1 plus 2x dx negative x squared plus 2x3 plus x4 dx. So when we integrate this, it gives rise to negative x raised to the power 3 minus x squared over 2 minus x raised to the power 6 over 30 minus x raised to the power 5 over 10, and then over 10 minus x raised to the power 4 over 12. So we can also go ahead and obtain when n equal to 2 as y2 negative 3 L inverse of y1 prime minus L inverse of a1, like this. We're going to project our results for y0 and a1. So that means for y0 and y1, we have y1, which gives x negative 1 over 2 x squared negative x raised to the power 3 negative 1 over 12 x raised to the power 4 1 over 10 x raised to the power 5 negative x raised to the power 6 over 30 plus other terms. So thank you for listening.